Hi students, welcome back to Alchemy Online Chemistry. Today we are going to discuss 7 crystal systems and 14 Bravais lattices. Plus 2 similar syllabus solid state part 3 നമ്മൾ വന്ന് ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് 7 ക്രിസ്റ്റൽ ടൈപ്പുകളെ കുറിച്ചും അതിനകത്ത് വരുന്ന 14 ബ്രവൈസ് ലാറ്റിസസിനെ കുറിച്ചുമാണ്. ഓക്കെ, പ്രീവിയസ് വീഡിയോയിൽ കഴിഞ്ഞ വീഡിയോയിൽ നമ്മൾ പറഞ്ഞു എന്ത് 4 ഡിഫറെൻറ്റ് ടൈപ്സ് ഓഫ് യൂണിറ്റ് സെൽ, ദാറ്റ് ഇസ് സിമ്പിൾ, body centered, face centered, end centered. So, okay, now 7 types of crystals are there. The classification of this crystal is based on the axial side and axial angle. അതായത് 7 ടൈപ്പ് ക്രിസ്റ്റലാണ് നമുക്കുള്ളത്. ഈ ക്ലാസിഫിക്കേഷൻ എന്തിനെ ബേസ് ചെയ്തിട്ടാണ്? നമ്മൾ കഴിഞ്ഞ ദിവസം പറഞ്ഞിരുന്ന ആക്സിയൽ സൈഡ് എ ബി സി, അതുപോലെ തന്നെ ആക്സിയൽ ആംഗിള് ആൽഫ ബീറ്റ ഗാമ. ഈ എന്താണ് 3 സൈഡും 3 ആംഗിളും വെച്ചിട്ട് നമുക്ക് വി ഹാവ് 7 ടൈപ്സ് ഓഫ് ക്രിസ്റ്റൽ. വാട്ട് ആർ ദോസ് 7 ടൈപ്പ് ഓഫ് ക്രിസ്റ്റൽസ്? ദാറ്റ് ഈസ് ക്യൂബിക്, ടെട്രാഗണൽ, orthorhombic, hexagonal, rhombohedral or trigonal, monoclinic, triclinic. So these are the 7 types of crystals. Okay, so what are the difference between these 7 types of crystals? We can discuss. In 7 types of crystals, see, first one, cubic. In cubic, the axial side A is equal to B is equal to C. That is all the sides. We know that here. We already discussed. This is what A, this is B, this is C. A, B, C. All these lengths are equal. Cubic A is equal to B is equal to C. Okay. Then angle, this angle gamma, this is alpha, this is beta. The alpha is equal to beta is equal to gamma is equal to 90. So when A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90, it is called a cubic crystal. Suppose if we get a crystal, if someone say it is a cubic crystal, now what type of unit cells are possible here? What types of unit cells are possible here? In this case, we have 3 types of unit cell: primitive or simple, body centered and face centered. Suppose if you get a crystal, someone says you that the crystal is cubic, you can ask what type of unit cells are present in this. So here that may be what simple or primitive, and body centered cubic may be there, and face centered cubic may be there, but not end centered or base centered. So basic crystal, that is cubic, contain 3 types of unit cell or 3 types of space lattices are possible. What are the 3 types of space lattices? Simple or primitive, body centered cubic and face centered cubic. Okay, so next one is what? Next one, tetragonal. In tetragonal, A is equal to B is not equal to C, but alpha is equal to beta is equal to gamma is equal to 90. Okay, in this case, how many unit cells are possible? What type of unit cell is possible? Primitive and body centered are possible. Primitive and body centered are possible. Now third type of unit cell, orthorhombic. In orthorhombic, A is not equal to B is not equal to C, but alpha is equal to beta is equal to gamma is equal to 90. Here in orthorhombic we can get simple or primitive, body centered, face centered, end centered. All the 4 types of unit cells are present in orthorhombic crystal. Suppose if you get a orthorhombic crystal, if someone asks you what is the type of unit cell, there may be what simple or primitive unit cell orthorhombic, body centered unit cell what orthorhombic, face centered unit cell orthorhombic, and end centered or base centered unit celled orthorhombic. So these are the 4 possible types of orthorhombic space lattices. Okay, next one is what? Hexagonal. In hexagonal, A is equal to B but not equal to what? C. A is equal to B but not equal to C. alpha is equal to beta is equal to 90. Alpha is equal to beta is equal to 90. But gamma is not equal to 90. Gamma is equal to 120. Gamma is equal to 120. In this type of crystal, only one type of unicell, that is only primitive or simple is possible. Only primitive or simple is possible. Okay. So that is the next crystal system. Now next one, what? Rhombohedral or trigonal unicell. In rhombohedral or trigonal unicell, A is equal to B is equal to C, alpha is equal to beta is equal to gamma not equal to 90. A is equal to B is equal to C, alpha, beta, gamma are equal but not equal to 90. This is called what? Rhombohedral or trigonal. Okay. In this type also we have only one type of space lattice or unicell, that is what? Simple or primitive. Simple or primitive. So, okay. Next one is what? Next unicell and next crystal system is what? Monoclinic. In monoclinic, A is not equal to B not equal to C. That is, three lengths or three sides are different. Alpha is equal to gamma is equal to 90, but beta not equal to 90. Alpha is equal to gamma is equal to 90, but beta not equal to 90. In this monoclinic unicell, in monoclinic crystal, two types of unicells are possible. What are the two types of unicell possible in monoclinic crystal? That is primitive or simple and end-centered or base-centered. End-centered or base-centered. That is what? Monoclinic. The last one, triclinic. Triclinic, A is not equal to B is not equal to C, alpha not equal to beta not equal to gamma not equal to 90. മൂന്ന് സൈഡും ഈക്വൽ അല്ല, മൂന്ന് ആംഗിളും എന്തല്ല ഈക്വൽ അല്ല. അങ്ങനെയാണെങ്കിൽ അതിനെ പറയുന്ന പേരാണ് ട്രൈക്ലിനിക്. ഓക്കെ. അതിനകത്ത് ഏത് മാത്രമേ ഉള്ളൂ? ഒരൊറ്റ ടൈപ്സ് സ്പേസ് ലാറ്റിസ് അല്ലെങ്കിൽ ഒറ്റ ടൈപ്പ് യൂണിസെല്ലേ പോസിബിൾ ഉള്ളൂ. അതേതാണ്? പ്രിമിറ്റീവാണ്. അങ്ങനെ ആക്സിൽ സൈഡും ആക്സിൽ ആംഗിളും വെച്ച് നോക്കുമ്പോൾ നിങ്ങൾക്ക് ഇവിടെ കാണുന്ന പോലെ എത്ര ടൈപ്സ് ക്രിസ്റ്റൽസ് പോസിബിൾ ആണ്? 7 type crystals possible. That is based on axial side and axial angle. We have 7 types of crystal system. But in each crystal, different types of space lattices are possible or unicell are possible. If you check on the basis of the unicell or space lattices, we have 14 Bravais lattices or 14 space lattices, that is called Bravais lattices. In cubic, we can see what? How many types? Primitive or simple and body centered and face centered. In tetragonal, we have what? Primitive and body centered. Orthorhombic, we have primitive, body centered, face centered, end centered. Hexagonal, we have only primitive. Rhombohedral or trigonal, we have primitive. Monoclinic, we have primitive and end centered or base centered. Triclinic, we have what type of space lattices? Only primitive or simple. So total, how many space lattices are possible in these 7 crystal system? 14 Bravais. 14 space lattices are possible. These 14 space lattices are called 14 Bravais lattices. So the total number of space lattices belonging to all these 7 types of crystal systems are 14. These 14 space lattices are called Bravais lattices. Simple ആയിട്ട് പറഞ്ഞാൽ ആംഗിളും സൈഡും ബേസ് ചെയ്തിട്ട് നമുക്ക് 7 ക്രിസ്റ്റൽ സിസ്റ്റം ഉണ്ട്. ഈ 7 ക്രിസ്റ്റലിലും എല്ലാ ടൈപ്പ് യൂണിസെല്ലും പോസിബിൾ അല്ല. സിമ്പിൾ ക്യൂബിക് എടുക്കുകയാണെങ്കിൽ ക്യൂബിക്കിൽ പ്രിമിറ്റീവ് യൂണിസെല്ലിൻ്റെ ക്യൂബിക് ഉണ്ടാവാം, ബോഡി സെൻറ്റേഡ് യൂണിസെല്ലിൻ്റെ ക്യൂബിക് ഉണ്ടാവാം, ഫേസ് സെൻറ്റേഡ് യൂണിസെല്ലിൻ്റെ ക്യൂബിക് ഉണ്ടാവാം. അങ്ങനെ 3 ടൈപ്പ് അവിടെ ഉണ്ട്. അതുപോലെ തന്നെ എന്താണ്? ടെട്രാഗണൽ എടുക്കുകയാണെങ്കിൽ പ്രിമിറ്റീവ് ഉണ്ടാവാം, ബോഡി സെൻറ്റേഡ് ഉണ്ടാവാം. അതുപോലെ എന്താണ്? നമ്മളുടെ ഓർത്തോറോംബിക് എടുക്കുകയാണെങ്കിൽ അവിടെ പ്രിമിറ്റീവും ബോഡി സെൻറ്റേർഡും ഫേസ് സെൻറ്റേർഡും എൻ സെൻറ്റേർഡും ഉണ്ടാവാം. അതുപോലെ ഹെക്സാഗണൽ എടുക്കുകയാണെങ്കിൽ അവിടെ പ്രിമിറ്റീവ് മാത്രമാണ്. അതുപോലെ ട്രയഗണൽ ഓർ റോംബോഹെഡ്രൽ എടുക്കുകയാണെങ്കിൽ അവിടെ പ്രിമിറ്റീവ് മാത്രമാണ്. മോണോക്ലിനിക്കലി പ്രിമിറ്റീവ് യൂണിസെൽഡും ഉണ്ട്, ബേസ് സെൻറ്റേർഡ് യൂണിസെൽഡും ഉണ്ട്. അതുപോലെ ട്രൈക്ലിനിക്കൽ ഏതാണ്? പ്രിമിറ്റീവ് മാത്രം. അപ്പോൾ ആക്സിയൽ സൈഡും ആക്സിയൽ ആംഗിളും വെച്ച് നോക്കുമ്പോൾ നമുക്ക് 7 ക്രിസ്റ്റൽ സിസ്റ്റം കിട്ടും. അതേസമയത്ത് യൂണിസെല്ല് വെച്ച് 7 എണ്ണത്തിൽ നമ്മൾ യൂണിസെല്ല് വെച്ച് ക്ലാസിഫൈ ചെയ്യുകയാണെങ്കിൽ 14 എന്താണ്? സ്പേസ് ലാറ്റിസസ് ആർ പോസിബിൾ. That is called 14 Bravais lattices. Next topic, that is close packing and voids. Close packing. What is close packing? The arrangement of the particles in a crystal. How the particles are arranged in a crystal. Of course, in a crystal, particles are arranged in a three-dimensional manner. So before going to the three-dimensional close packing, first we are discussing one-dimensional and two-dimensional close packing. Okay. For example, നമ്മൾ ഒരു ബിൽഡിംഗ് ഉണ്ടാക്കുകയാണെങ്കിൽ ആദ്യം എന്താണ് ബിൽഡിംഗ് 3 dimensional ആണ്, ആദ്യം 1 dimensional എടുക്കും, പിന്നെ അതെന്താണ് 2 dimensional ഫൗണ്ടേഷൻ ആക്കും, എന്നിട്ടല്ലേ 3 dimensionലേക്ക് വരിക. എന്നതുപോലെ നമുക്ക് ആദ്യം 1 dimensional ക്ലോസ് പാക്കിംഗ് പറയാം. 1 dimensional ക്ലോസ് പാക്കിംഗ് 1 dimensional ക്ലോസ് പാക്കിംഗ് 1D ക്ലോസ് പാക്കിംഗ്. In 1 dimensional ക്ലോസ് പാക്കിംഗ്, as you can see there, particles are arranged linearly. Particles are arranged linearly, in which one particle is in direct contact with how many particles? 2 particles. So the coordination number in 1 dimensional close packing is what? 2. This is all about what? 1 dimensional close packing. Now 2 dimensional close packing. What is 2 dimensional close packing? 2 dimensional close packing, 2D close packing, 2D close packing. 2D close packing, 2 types, square and hexagonal. Square and hexagonal. So first we are going to discuss the square. In square close packing, particles are arranged like this. This is one layer of particles. You can see there. Particles are arranged like this. That is, second layer is placed exactly below what first layers, then third layer exactly below what second layer. So if you name this layer A, this is also what A, this is also A, because all our layers are same. So this is what 2 dimensional square close packing, 2 dimensional square close packing. In this case, if you check the coordination number, that is one particle is in direct contact with how many particles? 4 particles. So the coordination number is 4. In 2 dimensional square close packing, the coordination number is 4. You can see there. Next, 2 dimensional hexagonal close packing. 2 dimensional hexagonal close packing. In hexagonal close packing, this is the first layer. Second layer is placed in the depressions of the first layer. That is, here we can place the second layer. Third layer is placed in the depressions of second layer. That is, here we are placing. This is 2 dimensional hexagonal close packing. Okay, so this layer is what? A. This layer is not exactly below what? First layer. Therefore, this layer we can what? Put as what? B. Now this layer, third layer, you can see first layer and it's exactly what? Below. This again exactly below. Okay, so this layer again we can say what? A. Now if you place the fourth layer, it will be exactly below what? Second layer. So this is again what? Again B. So AB type arrangement. AB type arrangement. In this arrangement, if you take one particle, that particle is in direct contact with how many particles? How many particles? 6 particles. So the coordination number is what? 6. Coordination number 6. You can see there. Okay, so this is what? 2 dimensional hexagonal close packing. Then formula 1, 2 dimensional square close packing, coordination number is what? 4. Next, 3 dimensional close packing. In 3 dimensional close packing, we have 2 types. That is, first one, from 2D square close packing, we are making 3D. That is 2D, that is base 2D ആണ്, 2D square ആണ്, base 2D square ആണ്. അതിൽ നിന്ന് എന്തുണ്ടാക്കുകയാണ്? 3D ഉണ്ടാക്കുകയാണ്. That is 3D from 2D square. So 2D square we made. That is here 2D square, 1, 2, 3, 4 coordination number. Now second layer we are placing above this. Here it is 2 dimension, we can draw above this. You can see the 3 dimensional video. See, anyway, we are placing the second layer. Second layer ഇതിൻ്റെ മുകളിൽ വെക്കുകയാണ്, ഇതിൻ്റെ മുകളിലാണ് വെക്കുന്നത്, ഇങ്ങോട്ട് വെച്ച് വരികയാണ്. ഓക്കെ, അപ്പോൾ second layer, this one, this is what? Second layer. Okay, this is second layer. Now third layer above this, that is first and second layer are exactly equal, because second layer, that is this blue color, is placed exactly above this black sphere. So exactly what above first layer, second layer is placed, third layer is placed above what second layer, and so on. So this type of arrangement is called what AA type arrangement, because all layers are what equal. All layers are equal. This is called three-dimensional from 2D square close packing. Okay, here it is, if you analyze this, you can see it is equal to simple cubic crystal. Simple cubic crystal. If you take one portion if you take, you see this is what top 4 particle, and black one is what bottom 4 particle. That is simple cubic. Simple cubic. You can see here. This is similar to what simple cubic. Here 4 particle bottom. Here again what 4 particle bottom. Okay. Now how many particle top? Here how many particle? 4 top particle. That is, this is the top of that cube. This black sphere is what bottom of that cube. Okay, it is exactly equal to what simple cubic crystal. Simple cubic crystal. Simple or primitive cubic crystals. Cubic means A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90. Now here the coordination number. Here the coordination number is what? What is the coordination number here? That is one particle is in direct contact with how many particle? One particle is in direct contact with how many particle? That is the coordination number. What is the coordination number here? See, suppose you consider this blue sphere. This blue sphere, consider. This blue sphere is in contact with 4 blue sphere of the same layer. That is second layer. Second layer is what? Blue. That blue sphere is in contact with the 4 sphere in the same layer, and one layer below what? That is black. And if you place third layer, one above. So one particle, that is this particle, in contact with how many sphere in the same layer? 4 sphere. Now if you place the third layer, one more here, and if you place one layer below, one sphere there. Total how many? 6. Now second type, three-dimensional close packing from two-dimensional hexagonal close packing. Two-dimensional hexagonal close packing. That is again classified into 2 types. That is HCP, that is hexagonal close packing. Already we discussed one hexagonal close packing, that is in two-dimensional. Three-dimensional also we have one hexagonal close packing. Okay, 3D ilum namukku enduണ്ട് ഒരു hexagonal close packing ഉണ്ട്. വേറെ ഒന്നാണ് CCP അല്ലെങ്കിൽ FCC. CCP or FCC, another type. That means from 2D hexagonal we can make 2 3-dimensional close packing. 2 3-dimensional close packing. What are 2 3-dimensional close packing? One HCP, another one is what? CCP or FCC. CCP cubic close packing, FCC face-centered cubic close packing. See here, this is what 2-dimensional hexagonal close packing. From this we are going to make what? 3-dimensional close packing. So first what we are doing, we are placing the second layer in the depressions of the first layer. Second layer in the depressions of first layer. So this is what? First layer. The gap between these 3 spheres is called triangular voids. What is? Triangular voids. So we are placing the second layer over that triangular void. This is second layer. Now here again we are placing. Okay. Now you can see one thing. When we place this second layer, this triangular void is covered by a red sphere, but this one is not. Again, this one is covered, this one is not. This one is not covered. Okay, this one is not covered. This one covered, this one is not covered. This one covered, this one is not covered. So alternate triangular voids are what? Covered. Now again we are placing here. In this case also you can see this triangular void is covered, this one is not covered, this one covered, this one is not covered, this one covered, this one is not covered. That is alternated triangular voids are covered. Okay, now we are going to place the third layer. Third layer we are going to place. Okay, if you place, see here you can see a gap. Here you can see a gap. That gap is known as what? Or that space is known as what? Tetrahedral voids. Tetrahedral voids. Why? Because see here, you just imagine this 3 red sphere. Just 3 red spheres are there. Okay, 3 red spheres. This is a triangular void. Over that triangular void, that is below that triangular void, this is a red sphere, this is another red sphere, this is another red sphere. Below or above that triangular void, one more sphere is there. So we can place one more sphere. Here I am placing one more sphere. Now this gap is called what? Tetrahedral void. Tetrahedral void. T. Tetrahedral void is tetrahedral void. Tetrahedral void. Represented by the letter T. Why it is tetrahedral? If you connect the center of this four sphere, you will get a tetrahedron. You can see there. You will get a tetrahedron. That's why it is called what? Tetrahedral void. So this is a tetrahedral void. We are representing T. Okay. This is another tetrahedral void. Okay. Here we will be having, that means if you make one more sphere here, here we have one more tetrahedral void. So this is tetrahedral void. Now you can see another thing. You just listen. In this case, that is in first black layer, the uncovered trigonal void and the trigonal void of this red layer what overlap. That is black trigonal void. You can see there like this. This is the black trigonal void. Okay, clear. Now red trigonal void, that is red layer trigonal void is like this. You can see here like this. That both trigonal voids are overlapping each other. Both the trigonal voids are overlapping each other. It is not covered yet. It is what still open. Now this new void is called octahedral void. What is octahedral void? Octahedral void. Octahedral void. We can represent as O. That means the uncovered trigonal void of first layer, that is black layer, and the trigonal void of second layer, that is this red layer, overlap in such a way that their apexes are in opposite direction. Apexes are in opposite direction like a star. This new void is called what? Octahedral void. So octahedral void, how we can draw it? See, octahedral void. See, this is the 3 particles. Now second layer particles are coming. How many particles? 3 particles, red. This is another one. This is another one. This is another one. Okay. So this gap is called what? Octahedral void. Why it is octahedral void? If you connect the center of all these 6 spheres, you will get an octahedron. Octahedron you learned in chemical bonding. What is octahedron? It will be like this. It will be like this. Okay. A regular octahedron you will get. Octahedral shape. We learned in the previous chapter, chemical bonding +1. Okay. So you will get an octahedron if you connect all this. You can see there. Okay. So this is what? Octahedral void. So octahedral void we are denoting by O. This is what? Octahedral void. This is another octahedral void. This is another octahedral void. Okay. Here we will be having one octahedral void, one octahedral void. Here again what? Octahedral void. So octahedral void is represented by O and tetrahedral void is represented by what? T. Now we are going to place the third layer. Third layer I am going to place. If I place the third layer over the tetrahedral void, that will be like this. See, this is the third layer. This third layer is exactly above this first layer. You can see black and blue. Both are what? Similar. So this type of arrangement, first layer what? Black, second layer is what? Red, third layer blue again what? Same as what? First layer. So this type of arrangement, AB arrangement. Because first layer black, second layer red, third layer blue again exactly above what? First layer. So AB type arrangement, that is called what? AB type arrangement is called what? HCP or hexagonal cross packing. Hexagonal cross packing, 3-dimensional hexagonal cross packing. 3-dimensional hexagonal cross packing. AB type arrangement, first layer black, second layer red, third layer blue, again exactly above what the black you can see here. Therefore it is what AB type arrangement, HCP. Here the coordination number is 12. One particle is connected with 6 in the same layer, you can see there, and 3 above, 3 below. Total how many? 12 coordination number. What is coordination number? 12. 6 in the same layer, one particle 6 in the same, coordinated with the 6 particle in the same layer, 3 particle with the 3 particle in the above layer and 3 particle in the bottom layer. അതായത് ഒരു പാർട്ടിക്കിൾ 6 പാർട്ടിക്കിൾ അതേ ലെയറുമായിട്ട് എന്ത് ചെയ്തിട്ടുണ്ട്, കണക്ട് ചെയ്തിട്ടുണ്ട്. 3 പാർട്ടിക്കിളുമായിട്ട് എന്താണ് മുകളിലുള്ള ലെയറുമായിട്ട് കോർഡിനേഷൻ ഉണ്ട്, 3 എണ്ണം താഴെയിലും എന്തുണ്ട്, കോർഡിനേഷൻ ഉണ്ട്. ദിസ് ഈസ് കോൾഡ് HCP arrangement. What is HCP arrangement? Now what is FCC or CCP? FCC or CCP? In FCC or CCP we can place the third layer over octahedral void. See, we are placing the third layer over octahedral void. Over octahedral void. Is it equal to second layer? No, it is what different from what second layer, because it is not exactly similar, not coincide with what second layer. It is not coinciding with what first layer, that is black. So this arrangement A, B, again this third layer is what C, because it is placed over what octahedral void. If third layer is placed over tetrahedral void, first and second layer same in both cases, HCP and CCP. ഒന്നാമത്തെ രണ്ടാമത്തെ ലെയർ HCPയിലും CCPയിലും സെയിം ആണ്. മൂന്നാമത്തെ ലെയർ വെക്കുന്നിടത്താണ് ഡിഫറെന്റ്. ഇൻ തേർഡ് ലെയർ ഇസ് ദ ഡിഫറെന്റ്. ഇഫ് തേർഡ് ലെയർ ഇസ് പ്ലേസ്ഡ് ഓവർ ടെട്രാഹെഡ്രൽ വോയിഡ്, ഇറ്റ് ഈസ് കോൾഡ് AB arrangement and HCP coordination number is what 12. If third layer is placed over octahedral void, you can see there octahedral void, then it is first layer A, second layer B. This third layer is not coinciding with the first or second layer, so it is represented as what C. So this type of arrangement A B C A B C, this type of arrangement is called what? FCC or CCP arrangement. FCC or CCP arrangement, face centered cubic close packing or cubic close packing, face centered cubic or cubic close packing. Here also the coordination number is 12. ഇവിടെയും എന്താണ്, കോർഡിനേഷൻ നമ്പർ എത്രയാണ്? 12 ആണ്. One particle is coordinated with 6 particle in the same layer, you can see there, and 3 on the top layer and 3 on the ബോട്ടം ലെയർ. അതായത് ഒരു പാർട്ടിക്കിൾ അതിൻ്റെ തന്നെ എന്താണ് ലെയറിലുള്ള 6 പാർട്ടിക്കിളായിട്ട് എന്ത് ചെയ്തിട്ടുണ്ട്, കോർഡിനേഷൻ ഉണ്ട്. 3 എണ്ണം മുകളിലുമായിട്ടും 3 എണ്ണം താഴെയിലുള്ള പാർട്ടിക്കിളുമായിട്ട് കോർഡിനേഷൻ നമ്പർ ഉണ്ട്. സോ ടോട്ടൽ നമ്പർ ഓഫ് കോർഡിനേഷൻ നമ്പർ ഇൻ FCC or CCP is what? 12. So remember, in FCC and HCP only the difference is what? Third layer is the difference. If third layer is placed over the tetrahedral void, it is called what? HCP. If third layer is placed over the octahedral void, it is called FCC or CCP. In both cases the coordination number is what?